Okay, so for GP number 1, this is going to be titled Identifying Parts of a Parabola. There are going to be 2 different graphs that we're going to look at here, and those were included on the printables page. So our directions are to identify the listed items. So for A, we are going to start with the graph that faces upwards. It's a taller, skinnier graph. Sorry, I didn't have those cut out already. So we're starting with this graph here. So go ahead and get that graph and glue it in. All right, so we have quite a few things that we're going to list. So I'm just going to write them as we go. The first thing we want to identify is the axis of symmetry. So our axis of symmetry is, if you recall from the vocab, the line that goes through the vertex. So that's this line here. So our axis of symmetry goes through the x-axis at -2. So the equation of that is x equals -2. The next thing we're going to identify is the vertex. And the vertex is the highest or lowest point on the graph. It is also the point on the graph that our axis of symmetry intersects. So this point right here is our vertex, and that is the point -2, -3. Now keep in mind that the axis of symmetry and the x-value vertex are always going to be the same value. We just write them differently. The next thing we're looking for is whether the vertex represents a maximum or a minimum. And you'll be asked that. Does your vertex represent a maximum value or a minimum value? And so it's just kind of something I want you to think about logically. If it's the very lowest point on our graph, then it is the very minimum of our graph. So I'm going to like to just go ahead and circle or box off the word minimum. The vertex is a minimum value. The next thing is, what is the max or min? And I know we just identified it as a minimum, but what is the max or min value? So what is the very minimum value of our graph? So this number actually will pop up in a couple of other places. If it's the very bottom of our graph, we've talked about that this week. The very bottom of our graph is here, and that value is -3. So the -3 is also part of our vertex, but that happens to be the y value. So the minimum value of our graph is at -3. Now, when you identify the maximum or the minimum value, it's implied that we're talking about the y value. So we can just simply write the number value next to it. Then we have X-intercepts. The X-intercepts are where our graph crosses the x-axis. And that is here and here. Those are points, so we need to write them as ordered pairs. The first one at -3, 0, and the second one at -1, 0. Then we have y-intercept. The y-intercept is where our graph crosses the y-axis, and that is right here at 0, 9. Now, something that's new to us is something called the increasing interval. Now, we've heard that word increasing before. We talked about that looking as our graph goes to the right. Is our graph increasing or decreasing? So if you take a look at this graph here, you'll see it's increasing because it's going up as it goes to the right. However, this one's a little bit different because it asks for the increasing interval. And the interval is the piece of the graph that is actually increasing. Now with a line, either the whole thing is increasing or the whole thing is decreasing. But now that we have this parabola-shaped graph, this U-shaped graph, that's not the case. So we're actually going to talk about the increasing interval and the decreasing interval. Okay, so what I want you to do is grab two different colors. I'm going to use red and green. And starting at the very left side of your graph, I want you to hover over the graph and trace. We're not going to actually draw on it. We're just kind of hovering and just kind of moving our pen with it. So notice that as I go down with my graph or go along with it from left to right, again, always from left to right, notice that my marker is decreasing. So on this side of the graph, it's decreasing from the left side to the right side. Then it's decreasing, it's decreasing, it's decreasing, it's decreasing, then it stops decreasing right here. Stops decreasing here. And then if I keep going, it now turns around and now it's increasing as it goes to the right. So this side of the graph is increasing. Now, there's still these arrows here. Remember, there's going to be arrows at the end of our graph unless there are endpoints, okay? Even though sometimes the arrows might not be there. So we can just draw those on. So basically what we're doing here is we're splitting our graph into two pieces. This side of our graph, the left side of our graph, is decreasing and the right side of our graph is increasing. So we're looking to write the interval at which it's increasing and the interval at which it's decreasing. So the right side of the graph is the side of the graph that we said is increasing. So we're reading it from left to right. What does that sound like? What else have we talked about that we read from left to right? Well, the domain, right? The domain is read from left to right. Well, so is the increasing interval and so is the decreasing interval. So basically what we're doing here is we're taking our domain and we're splitting our domain in half. So first we want to look at the right side of our domain. So that starts at this value here, at the axis of symmetry, which is where x equals -2. Now it makes sense because our domain deals with our x values. So we're splitting, again, that domain into two different parts. So our graph begins to increase at the axis of symmetry, which is -2. So it increases from -2 all the way to the right. All the way to the right is positive infinity. So it's increasing from -2 less than or equal to x less than positive infinity. And it's decreasing on the left-hand side. Well, all the way to the left is negative infinity. So from negative infinity, less than x, less than or equal to, well, again, it's decreasing, it's decreasing, it's decreasing. It stops decreasing at that same value. So it stops decreasing at the axis of symmetry, which is -2. So these same values will be contained within the increasing and decreasing intervals. You just have to make sure that you're putting them in the correct place, whether it's at the beginning or the end, because it's not going to be the same every time. So next we have the domain. Well, our domain is read from the left side of the graph to the right side of the graph. So the domain all the way to the left side of our graph is negative infinity, and it goes all the way to the right, which is positive infinity. So negative infinity is less than x is less than positive infinity. So take a look at our intervals here, and our intervals are from negative infinity to positive infinity, but we cut the domain at the axis of symmetry. And that's going to happen every time. The range, remember the range is the very bottom of the graph to the very top of the graph. The very bottom of the graph is here at -3, which we talked about earlier with that minimum value, right? The very bottom of the graph is at -3, so -3 is less than or equal to y is less than, and the very top of the graph is going to be positive infinity. All right, the last thing I want to talk about here is the average rate of change. And in my next GP, I'm going to go ahead and start abbreviating things. The average rate of change over the interval from -4 to -3. The average rate of change over the interval from -4 to -3. -3. Okay, so on my graph, I want to find the point on my parabola where x equals -4, which is up here. So that's the point -4, 9. To where my graph, or to where my x value is -3, which is right here at -3, 0. Now, if I draw a line between those 2 points, notice that that line is decreasing, which means that we should have a negative average rate of change or average slope when we work through this. So we use our slope formula, y2 minus y1 over x2 minus x1. That's going to be 0 minus 9. x1, y1, x2, y2. 0 minus 9 divided by -3 minus a -4. That's going to be -9 divided by -3 minus a -3 plus 4 is a +1. So our slope is -9. And you guys do need to make sure that you're showing this work every time you do average rate of change or average slope. Anytime you're using 2 points, or if you're given the information on the graph, you should be showing your work every time.